Some stars have enough mass to end their life cycle with a bang, called a supernova, while smaller stars like our sun are destined to whimper. But for some time now, astronomers have predicted a special middle ground, where a star shouldn't go supernova, but it does anyway. And this week in Nature Astronomy, researchers claim they've actually observed this kind of supernova for the first time. As stars progress through their lives, they fuse atomic nuclei in their cores into heavier elements and release a bunch of energy. That energy keeps all the star's mass from collapsing in on itself under the power of gravity until it runs out of fuel. For stars that are more than 10 times the mass of our sun, running out of fuel leads to what astronomers call a core collapse supernova. But for stars that are less than 8 solar masses, their cores are stable enough to just shrink down into an object called a white dwarf. Those white dwarfs, if they manage to steal enough matter from another star, can undergo a second type of supernova. But for the past 40 years, astronomers have hypothesized a third type of supernova for that intermediate range of 8 to 10 solar masses. Supernovas for everyone. When they run out of fuel, these star cores end up made of elements like oxygen, neon, and magnesium. And importantly, they also have a lot of what astronomers call degenerate electrons. These are electrons that sit at their lowest possible energy state allowed by the laws of physics. And it means that they act kind of like a scaffold, stopping the core from collapsing any further. But if an electron happens to collide with a nucleus in just the right way, the nucleus will capture and cannibalize the electron and release a ton of energy. So astronomers hypothesized that when one of these cores was dense enough, the magnesium and neon could capture enough electrons to reignite the core's nuclear furnace, all while consuming ever more electrons, which ultimately destroys the structural integrity of the core. The inside converts into an even denser neutron star, and the outside explodes as an electron-capture supernova. Over the past several decades, astronomers have come up with a list of features they would be able to observe in a supernova signature and the star it came from to suggest it could be one of these electron-capture ones. Things like an unusual chemical composition and a relatively weak explosion. And based on previous studies, the best candidate astronomers had for a remnant of an electron-capture supernova was the Crab Nebula. But the light from that event first reached Earth all the way back in 1054, which safely predates our ability to observe it in detail. So when one team found a weird, brand new supernova back in March of 2018, dubbed 2018 ZD, they used a bunch of different data, tracking it from just a few hours after the explosion was triggered, to see if its signature matched an electron-capture supernova. They also checked some prior data collected from other supernovas, but 2018 ZD was the only one to meet the 6 specified requirements, making it the best evidence for electron-capture supernovas to date. So the hunt is just beginning, going back into data from previous supernovas to figure out if any of them share enough similarities to call for an updated classification, including the Crab Nebula. And there's bound to be new electron-capture supernovas popping off throughout the universe too, so astronomers will eventually figure out how frequently they actually happen. And with a larger sample size, they can suss out all the nuances that come from making a star in just the right mass range go boom. But a quiet boom, because sound doesn't travel in space. In more local news, astronomers continue their hunt for life in the solar system, but the latest news might dash your hopes. A new study this week, also in Nature Astronomy, has sent the odds of life on Venus plummeting, finding that there isn't enough water in our evil twins clouds to support even the most extreme kinds of life as we know it. Unlike the giant floating bags of water in Earth's atmosphere, Venus's clouds are made from droplets of sulfuric acid. But that hasn't stopped scientists from wondering if some kind of life could survive in those clouds given enough liquid water. However, in this paper, the scientists say previous research has been ignoring how little water there actually is in that supposedly habitable area. To show that, they used a measure called water activity, which is basically equivalent to relative humidity. But where relative humidity tells you how much water is in the air compared to how much the air could possibly hold, water activity tells you how much of the water is actually available for use. It depends not just on the local atmospheric pressure and temperature, but what other substances are present. The droplets in Venus's clouds are made of sulfuric acid dissolved in water, but the presence of non-water molecules actually decreases the ability ability for any water molecules that are there to go out and react with other things, like the molecules inside hypothetical alien cells. So even though we know of life on Earth that can tolerate a lot of sulfuric acid, the concentration of acid in Venus's cloud droplets could make it too dry for life as we know it to live. The team calculated the water activity in the supposedly habitable region to be over 100 times less than what life on Earth needs. In addition, the concentration of sulfuric acid would be way too high for any kind of life as we know it, though the researchers didn't rule out life as we don't know it. However, the team did do calculations for water activity elsewhere in the solar system to see if there were some places beyond Earth that might be a bit wetter, which could help guide our search for life on Mars and Jupiter and beyond. Thank you for watching this episode of SciShow Space. If you would like to help us keep bringing you exciting news about the universe every single week, you can get started at patreon.com/SciShowSpace.